Hello, everyone. Welcome to our today's webinar from Ruijie, Design Your Wi-Fi Network with Ruijie's Cloud Site Survey Planner. My name is Vladimir Ortega. I'm a pre-post sales engineer for EPCON, and let's give a couple of minutes so people can join. I don't know if the attendees that are today can hear me well. If you can hear me, please raise your hand. Okay, guys, if you can hear me well, can you please give me some confirmation? Seems that we have some kind of problems with the audio. I don't know if you can hear me this time. Can you hear me, guys? Can you hear me right now? If you can hear me, please can you please raise your hand? Okay, at this time I don't have confirmation from any of you guys that you can hear me well. Okay, says Miriam that she can hear me, right? I just put a question on the chat if you can hear me there. Okay, seems like Miriam is able to hear me. Okay, let's start with today's webinar. Sorry for the interruption today. Okay, my name is Vladimir Ortega. I'm a pre-post sales engineer from EPCOM, and today we're going to discuss our today's webinar, Design Your Wi-Fi Network with Ruijie Cloud Site Survey Planner. This is an interesting tool that is going to help us to design all the Wi-Fi coverage inside an area, let's say inside and outside bases as well. Okay, for this webinar, this topic today, I will recommend you to download the Ruijie app application on the App Store, iOS App Store, or Google Play Store. And it's really easy and convenient because you are going to have like a demo project over there, and this demo project is going to allow you to follow with me all the options that you can see, that you will find on the tool itself. So you can follow me with the demonstration, and you can do just practice and research what do we have over there. So as soon as you download it, and you need to register your account there, and please scan this QR code. Here you see the in this slide how easy it is to scan this code with the application. So I will give you like let's say 3 minutes to do this, and then we can start. Okay, let's get started. So let's begin first to explaining what is a Wi-Fi heat map. So basically, a Wi-Fi heat map is like a kind of it's a visual representation that could show you how much is the strength of a signal inside or outside an area, right? So this can be applied in an office, house, or building, whatever plan or area that you may have. This type of map really helps to identify zones with good signal and coverage, as well as the signal, as well as the areas where the signal is kind of weak or maybe non-existent, right? So in this way, you can, the heat map, the Wi-Fi heat map will facilitate us the optimization of the wireless network, correct? So in the resulting heat map, there are different colors. We will find different colors over there. Those are going to be some kind of representation of the signal strength. The first one is going to be the green, that is going to be that, or that is going to mean that we have like an strong and good quality signal. Yellow and orange, it means that that we will have a moderate quality signal, and red is a weak signal. If you find something in white or gray, no signal, or it's going to be existing there. You are not going to be any kind of signal, or maybe the signal is going to be really poor, right? So if you can see here, and you can appreciate, we have here in this heat map, let's say that this is a home. We have some access point ceilings, we have some IP cameras. They are conveniently distributed inside this area. So they will, this Wi-Fi heat map is going to allow us to see where we are going to have in the practice a good coverage, talking about the access point. So as you can see, there are some kind of yellow areas, those areas outside the home or the house. That means that they mean that the Wi-Fi signal is kind of moderate, so you are going still to have some kind of access to internet or to a network, but it's not going to be the best. So as soon as you reach those kind of levels, minus 65, minus 70, 75, 80 dBm, the signal is going to be really poor, and you're going to have like loss of packets regarding the transmission. So that is the thing with this Wi-Fi heat map that is going to allow us to check before we do the implementation, right? To see where we can accommodate the access points. And if we can see here in the next floor plan, we have here that we're installing just a home Wi-Fi access point or router, and we have a range extender, a home Wi-Fi range extender. Since that this kind of setup based on these two devices is insufficient for this area. So if you just see in there, we have like a living room, a master bedroom, master bath, dining room, kitchen, usually what we have on at home. This is not going to work really well because the signal is not the best, right? The heat map should be in green in order to provide full coverage to entire home. So let's say that we have like a few devices. The best way is try to put it into a good location, the optimal location. But sometimes even doing that, you will need to have more access point or devices in order to provide a full coverage in second area. We're just discussing here, let's say, a floor plan of a house, but what happens if it's I don't know, a mall or maybe an outside park and a stadium? This tool comes very handy at those moments because we can plan and design what we're going to install and what kind of bill of materials we are going to get in the future. So let's go with a proof of concept in order to demonstrate all this theory. So it's really nice to see here. Let me check one thing. Okay. As soon as we get into the Ruijie cloud, we log in into the session. I don't have any projects created here, but since this is something that we're going to design and plan for the future, let's say that we need to create a budget. What we're going to do is to go here into click here into the AA heat map. It's going to open us another tab, a new tab. And then I have here a couple of projects, but let's create a new one. So let's say that I'm going to call this home. And this is going to be like a design for a basic house for, let's say, 4 or 6 people family. We click here on OK. It's going to create us a new project, and then we can upload some kind of plan, right? A floor plan. Okay, there we go. So it's going to upload the floor plan. We can assign a name here, say home. And we have here, or we find here, two kind of options, right? The tool needs to identify the perimeter, let's say the area. So it's really easy to do it here with our Ruijie tool. And the first one is going to input the actual area. Let's say that, I don't know, we said that this is going to measure 120 square meters. So depending on this and assigning the floor height and enabling as well the wall recognition is going to really, or let's say, to recreate all the measures talking to these walls and internal walls and doors and windows even, but we can also do it by length. So it is going to be really easy if you have the area, because you can, let's say, just mark let's say a wall here, an internal wall, and just put there the actual length. I don't know, let's say that this length 1.5 meters, correct? So based on this, it will calculate all the entire area and the walls. Since we have here some kind of, let's say, open spaces, doors, we have the truncate wall tool where you can just click with a couple of clicks, you can delete and you can rearrange doors and open spaces as well. So let's say that this is a door and we need to click those spaces just to remove them. Some of them are automatically recognized, others don't. But it's really easy to do it with our mouse. So is something that we can achieve right here in the best way, correct? Okay, we have here this, and as soon as the walls are recognized, we can even draw a wall as well. We can truncate a wall, but we can even draw a wall. So let's say that in this way, I just removed this wall on purpose, but let's say that this is like a thick wall made of concrete, steel plate, so it's going to provide us or to give us the attenuation based on 2.4 gigahertz. So it says that the attenuation is between 25 and 30 dBi. So I can design here that wall and say, okay, this is a concrete wall, correct? But for this purpose or for this demonstration, you can also select other materials like a thin or medium, let's say brick or metal, maybe wood or some kind of glass. So it's really nice to see that option here because it allows you to design the walls and just to get like a more accurate representation, right? So the first thing that we're going to do, the first demonstration, is to do it just with in the manual way, let's say. So in this way, let's just recap. We uploaded a floor plan. We did some kind of edit on the plan. We removed some doors that don't belong to the floor plan, and then we have here the list of materials that we can use. So let's say that we're going to install like a couple of access point, ceiling access point. So let's say that I'm going to put two here, and then I can just move it around the floor plan in order to get the best coverage. Let's say that there are some areas like this one. Let's move it here on purpose just to have full coverage on the living room, the dining area, the family room, but we don't have let's say like a good coverage on the bedroom, right? So yeah, this is like a familiar and a common usage. So most of the people are going to be in the master bedroom, some bedrooms, living room, kitchen, dining area, maybe not in the laundry or master bath, but we can always solve this just using more access point, correct? So let's say that we can install here the RG 180. So we can install just one here and just move it into the bedroom. So if we put it here on the, let's say on this part, you're going to have a full coverage of this bedroom. We can also install a new one. So it's really nice because it allows you to see some kind of visual representation of how it's going to be the signal propagated inside the home. And in this way, you can create like a bill of material for this. So for this time, I can click here on, well, before we go into that, we can also check the signal simulation in 2.4, since 2.4 gigahertz band have like a more coverage due to the physical characteristics of the wave. You can also see how it's going to be the emulation if you are going to deploy the network just configuring 2.4 or 5 gigahertz. So it's really nice to see it here. We can click on export, and as soon as we click here, we can even we're going to have a bill of materials. So it's really nice because we can edit it. We can also include the, let's say, the cost. So let's say that the unit price for this thing is, let's say, I don't know, 20 bucks. Well, I think that I have to edit it here. Yes. So the unit price is 20 bucks, and for the other ones that are really more expensive, let's say that are 40. So you can export all these things. You can even increase the unit and replace it with some kind of free marks. It's going to give you the total cost, and you can export this value, right? So you can say that, as you can see here, we have some kind of topology design. You are going to have like a full report. It's going to give us the placement map, the heat map in 2.4, in 5 gigahertz, just doing the highlights as well, the flexible identification, the app and cloud management that provides Ruijie for a free license, multi-one, network security, etc. You can even edit and put your company logo here, the company name, the contact person, and it's really easy to export it because you can export it on an Excel or a PDF on a Word format. So as you can see here, it's really nice. We can also export this by viewing by devices or by floor. We only have one floor for this demonstration for this proof of concept. But it's really nice because in the past, this took like a lot of time. You need to open up your Excel spreadsheet and then just do the calculation, then just create like a table with some columns and rows and start putting there, dropping there the wall access point, the ceiling access point, the Unitarian presence, doing the calculation, etc. But never you will have like a topology, the placement design, some kind of visual representation of the signal that is going to be deployed on site. So it's really nice how all the technology or the TE field has evolved in order to provide this via web, correct? So going back, let's create another project, and so we can try the other way around. So let's call this new project home 2. Let's say that this is a villa or home. We're going to use the same floor plan. So we can see here on floor plan. This is the same one. Let's assign the same, another similar name, home 2. And then we're not going to design a wall, right? Just to create a scale based on the wall name that we just put it here. Let's say that this is going to have 120 square meters. Then just click OK with the wall recognition activated. It just did the same, just draw all the walls and identify the thick, the thin walls as well. And we just still need to do some kind of editing here just to remove some parts that it doesn't detect like an open spaces. Okay, here we go. So we have here our plan edited, and we can also continue drawing walls like I mentioned before. You can even change the scale if you want. You will have a lot of options, but this time, let's say instead of just dragging and dropping access point from this palette, let's say from these several options that we have here, we're going to use our new AI model, the Ruijie. So we have like two options at the moment, and talking about the auto AP placement mode. So the first one is going to be, let's say the professional plan. Is really nice because you can enter a lot of each area, and based on that, it's going to give us like an estimate, an approximate of how many APs we're going to have inside this deployment. So let's go with this first one. Okay, here we go. So identifying all the spaces here, and what we're going to do is just to select, right? So let's select the master bedroom area, and let's say that we're going to call it master bedroom, and we're going to put here, I don't know, how many people could be in a master bedroom area. Let's say that we are going to have 4 or 6 devices over there, right? Including TVs, a couple that have a couple of cell phones. Let's talk about this area. Let's call it kitchen area or living area, where maybe you spend most time of the day in that area with your family. So let's put here that we're going to have even 3 devices, concurrent devices at the same point. Where you going to use this another living room? Let's call it living 2. And let's say that we're going to have custom maybe 20 devices. We click here on next. We just need also to tell to the program that we're going to have some kind of areas that we're not going to have access point. So maybe we're not going to install an access point on master bathroom, not even on the auxiliary bathroom, not even on the laundry, etc. So here, exit, okay. And then as soon as we have selected the critical areas and the AP-free areas, we're going to click here, auto AP placement. So it's going to run several iterations of how it's going to, let's say, it's going to be the final result. And for this purpose, this is the professional, we're going to have a heat map, a good approximate of what we're going to have there, an estimate. And as soon as we click it on the other areas that are going to be free, he doesn't take in count those areas in order to do the calculation, right? But it's taking in count the living area, these 2 bedrooms, the another living area, and the master bedroom. So we have 3 kinds of, let's say, bill of material for this one. One is the professional. We're going to use here, let's say, if you can click here on the professional, we're using professional devices like the RAP 2200 enhanced and the RAP 1200P. We can also, let's say, I'm not going to say decrease, but let's say that we can maybe use an standard devices. So we're going to have the same coverage, but maybe we're not going to have the same throughput because we maybe our needs is not to transmit or broadcasting content, or maybe we don't have like kids that are going to play at home and consume like a high amounts of bandwidth. So you can go with the standard one, and you're going to have the same access point, or well, not the same access point, the same family access point, but not the, let's say, the highest one. But it's going to provide you a good coverage as well and a good throughput as well. The difference, if you can see here, is that we're using the professional here is the enhanced model, and here we're using this fast Ethernet model. So the traffic is going to achieve or is going to be up to 100 megs or more than that. And we also have the ultimate, that is something between the professional and the standard. So the recommendation is going to be the same location for the devices, but we are going to use here the, let's say, the general model for this one. So as soon as we click here, let's take it to this, let's say, to this ultimate recommendation, right? So as soon as we click here on apply, boom, it's going to calculate and it's going to hit us the button, and then we can export it as well, right? The same thing that we did just a moment ago. And the other one is really simple. Let's create a home tree. So yeah, I think that we're building some kind of residential area here. Let's use this. Let's take it to the same floor plan. Okay, it's this one. Let's call it home tree. Let's use the same automatic detection. Let's say that this area is going to measure 120 square meters. Water connection always enabled. Then we're going to design. We're going to remove some doors here that the program wasn't able to detect it at first. Some of them, they are already detected. I just need to delete them. But then, let's say for this first one, I can just refine it, right? And there you go. We have here our plan. Just edited. We still have all the options, the manual option. We're going to use again the AI, but in this time, instead of using the professional placement plan, we're going to use the quick placement plan. So we're going here to select this one and start quick placement. It's identifying the floor plan. And what it's going to do is just to identify and provide the best coverage for the entire home. In this option, we don't have the particularity to say, hey, we don't want this room free of access point. It's going only to give us where are going to be the best location for the access point and which one we're going to use. So if you can see here for the kitchen area, the dining area, family room, we're just going to use a ceiling access point, the 2200 enhanced. In this area of this living room here, we can use a wall access point, the 1200p. For this master bedroom, this is a bedroom, a wall access point of the same family or the same model, the 1200 is going to be enough for that. And for the master bathroom, we can use a wall access point as well. So as we can see here, we have 3 in total for the wall access point and 1 just 2 for the ceiling access point, just trying to provide the coverage for the entire home. We can just apply to the bone as well. And there we go. We can export it as well, and we can edit the codes, including you were going to have the heat map 2.4 in 5 gigahertz. It's really nice. You can also remember that you can edit your company information if you want to provide this boom to the client, right? In order to, let's say, give like a more fancy document to a client, and something more attractive in order to sell a project if you are some kind of integrator. This is everything regarding the AI model or the heat map, but we can also create a heat map for outside areas, right? So let's call it this, that I'm going to create a new project that I call it a port, right? So I will click here on universal. Let's leave it in that option this way at this time. But we can select here and just moving from wireless bridges, from WLAN to wireless bridges. So as you can see here, we have here some kind of terrain representation. Let's move to Paso, right, in US. So let's say that I need to cover all this area here on El Paso. I have, I don't know, some kind of deployments here, talking about some kind of homes, maybe you can do a plantation, whatever you need to cover. But it's really nice because this model is designed to provide a heat map, but just for point-to-point and point-to-multipoint. So it's really nice because we have bridges, and we can, let's say, install a bridge here and another here just to provide the coverage to this area. And as soon as we click here, it's going to give us some kind of heat map representation. If we click here on 5G, if you buy these bridges from Ruijie, as you can see here, it's going to give you an estimate of which bridges we can use to, let's say in this case, a point-to-multipoint scenario, right? So for this matter, what you're seeing is recommended us to use the EST310, that it has a coverage of up to 1 kilometer, but and you can tie up to 1 receiver up to 4 transmitters. So it's really convenient because I can also add more transmitters to this base receiver here, up to 4 devices. So it's really nice because using these maps, these global maps, all the entire world is located there. You can plan and design point-to-point links in open wide space areas, or you can even decide it in cities just to provide coverage to a park, to a stadium, etc. You can also export here this boom. Is going to be more likely the same or similar that we did before with the other ones, with the inside scenarios. And as you can see here, it's really nice because it's saying, okay, you need to buy this device, you need 3 of them. You can also edit the prices. It will give you some kind of topology representation, just establishing here the links between the receiver and the 2 transmitters. It will give you the placement plan, the real representation plan with the coordinates and all that stuff. And it's going to give you the heat map for the 5 gigahertz because this radio works in 5 gigahertz. We will also give you some kind of device installation. That this is really nice for integrators because it gives you some tips and procedures to install the devices, the radios over there, the antennas, and how do you need to install them. Talking about the azimuth, if you need to tilt down or tilt up 1 receiver or 1 transmitter, and it's going to give you as well the throughput, the total throughput that you're going to achieve with this setup. You can also edit the company information, and at the end, at the same as the previous one, you can also export it into an Excel file, a PDF file, and a Word file. So that's all, folks. It's really nice to use these Ruijie and Ruijie tool for heat maps. Let's remember that we can use in order if you want to deploy inside scenarios, indoor scenarios, we can also use the artificial intelligence model that is going to locate the best access point for that supplier, just achieving like an optimal way in order to deploy the devices over there. And we can also do parts here and outdoor scenarios like parks, stadiums, universities, campus, factories, etc., in order to provide coverage. So thank you very much for your attention today. I will give you here, we put here the QR code if you haven't scanned it yet. I will give some kind of minutes in order to answer some questions or doubts that you may have. So please feel free to put it on the chat box and I will answer it today. Okay, since that we don't have any questions today, so thank you very much for your attention today. It was really nice. Remember here that at EPCON we have an engineering team that is going to be able to help you if you have some project that you need to deploy or just help you into the design of this project. We have a team that is completely capable of achieving good results and providing like a good recommendation for you guys. And thank you very much. My name is Vladimir Ortega. I'm a pre-post sales engineer for EPCON, and have a good day. Thanks.